Alright, there's a second part to part C of number 52 to find the linear velocity of the pendulum when it's lined up with the vertical. So to find that, we actually have to do a couple different steps. First of all, you just kind of use the conservation of energy theorem, so you have K is equal to U, and then we just kind of plug in everything here. K is 1/2 the mass times the velocity squared, and U is mgy. But in this case, that's going to be mass times gravity times the height that our pendulum is at. So, and then to find the velocity, we just kind of solve for velocity over here. So we have mass times velocity squared is equal to 2 times the mass times the gravity times the height. And then we have velocity squared is equal to 2 times the gravity times the height. And velocity is equal to square root times 2 times the acceleration of gravity times the height of the pendulum. Excuse me. And then we find the height of the pendulum from our little diagram that we had at the start, TA, and we know that our acceleration is going to be equal to gravity times the sine of theta, and that at this point the height is going to be 1 minus the cosine of theta. So you can just plug that in for our h. That's going to be the square root of 2 gravity times 1 minus the cosine of theta. And then that'll give us the linear velocity at the point where the pendulum is lined up with the vertical line.